includes documentation, change management, backups, disaster recovery, safety practices, and scripting basics. These concepts tie everything together and reflect how IT work is done in real organizations. Part 4. Operational Procedures, Domain 4.0. 4.1 Safety Procedures and Environmental Controls. Technicians must enforce structural workplace safety protocols and environmental lifecycle management to protect personnel and hardware. Electrostatic discharge, ESD, mitigation. ESD can permanently damage internal microelectronics with unnoticeable voltages. Technicians must utilize an ESD wrist strap clipped to a grounded metal chassis component or work on conductive ESD mats. Critical exam fact: always disconnect an ESD strap when servicing high-voltage components like cathode ray tube, CRT, monitors, or internal power supply unit, PSU, components to avoid creating a ground path through the technician's body. Store uninstalled expansion hardware inside silver gray static shielding bags. Environmental protection and documentation. Safety data sheets, SDS, formerly known as Material Safety Data Sheets, MSDS, outline chemical compositions, storage limitations, first aid measures, and legal disposal mandates for toxic materials like batteries, toner cartridges, and cleaning solvents. Climate and infrastructure control. Server rooms require precise climate control. High humidity leads to condensation and internal short circuits. Low humidity generates high ambient static electricity, increasing ESD risks. High-draw server systems connect to an uninterruptible power supply, UPS, to filter power spikes, manage brownouts, and provide battery runtime to execute graceful system shutdowns during blackouts. 4.2 Documentation, change management, and asset management. Corporate infrastructure relies on detailed tracking schemas and strict operational review boards to control configuration drift. The change management cycle. To prevent ad hoc infrastructure changes from introducing catastrophic systemic downtime, organizations enforce a rigid change management workflow. 1. Document the purpose and scope of the proposed change. 2. Perform a formal risk analysis to evaluate business impacts or potential outages. 3. Formulate an implementation plan with an explicit step-by-step backout plan to revert configurations if the change fails. 4. Submit the proposal to the Change Advisory Board, CAB, for structural approval. 5. Schedule and implement the change during designated low-impact maintenance windows. 6. Document all changes, outcomes, and final configurations in the knowledge base. Asset management controls. Every enterprise device is cataloged with a unique, tamper-evident physical asset tag containing a barcode or serial identification string. This links the piece of hardware to a central inventory database tracking purchasing data, active user assignments, lifecycle status, and software licensing compliance. 4.3 Backup and disaster recovery architectures. Data preservation strategies dictate an organization's ability to recover from hardware failures, cyber attacks, or natural disasters. The 3-2-1 backup strategy. Maintain at least three copies of critical operational data, stored across two separate media types, e.g., local NVMe arrays and magnetic tape systems, with at least one copy located offsite or in a secure cloud repository. Backup execution methodologies. Full backup duplicates all targeted system data blocks completely. It resets the file archive bit attribute. It provides rapid recovery times, but requires massive storage footprints and long backup execution windows. Incremental backup only copies data blocks that have been modified since the last backup operation, full or incremental. It resets the file archive bit. It features ultra-fast backup execution times, but requires restoring the baseline full backup plus every subsequent sequential incremental file set, increasing recovery complexity. Differential backup copies all data blocks changed since the absolute last full backup. It does not reset the file archive bit. Backup times grow longer each day following the initial full backup, but recovery requires only 2 file sets. The baseline full backup and the latest differential file set. 4.4 Regulated data, privacy, and software licensing. IT technicians frequently access systems housing highly sensitive data domains governed by strict international compliance frameworks. Classifications of regulated data. PII, personally identifiable information, any data element that can uniquely isolate or trace an individual's identity, e.g., social security numbers, biometric profiles, mailing addresses, date of birth. PHI, protected health information, medical charts, clinical histories, diagnostic statements, and healthcare billing records protected under federal legislation like HIPAA, Health Insurance Portability and Accountability Act. PCDSS, Payment Card Industry Data Security Standard, a comprehensive global operational framework governing any entity processing, storing, or transmitting credit card and electronic payment indicators. GDPR, General Data Protection Regulation, a strict European Union regulatory framework enforcing data sovereignty, user consent data gathering, and an individual's structural right to be forgotten. Software licensing compliance. EULA, End User License Agreement, a legal contract defining the explicit terms, installation restrictions, and operational bounds governing software utilization. Open source versus proprietary. Open source software, e.g., GNU General Public License, permits users to inspect, modify, and redistribute the underlying source code freely. Proprietary models, e.g., commercial licenses, restrict source code access, enforce digital rights management, DRM, validation, and restrict software use based on per seat or concurrent user models. 4.5 Scripting basics and remote technologies. Automation and script execution allow administrators to manage thousands of enterprise endpoints efficiently without localized physical access. Script file types and interpreters. .bat/.cmd. Windows command prompt batch scripts used for basic shell automation. .ps1. Microsoft PowerShell scripts leveraging object-oriented terminal environments built on the .NET framework. .sh. Bourne/bash shell scripts executed natively across Unix, Linux, and macOS terminal shells. .ves. VB script files utilized historically across legacy Windows administrative automation tasks. .js. JavaScript files executed within client-side web browsers or server-side runtimes like Node.js. .py. Python scripts utilized for platform-independent tool scripting, automation, and data analysis. Basic scripting syntax elements. Variables, named memory storage allocations hosting dynamic text strings or numeric integer values, e.g., set username equals ktaylor. Environment variables, system-wide variables predefined by the OS tracking local system paths and parameters, e.g., %userprofile% or %systemroot%. Loops and conditionals. Programmatic logic structures like for, or, while loops that repeat actions across object datasets, and if/else statements that branch script actions based on explicit logical tests. Comments. Documented annotations within code blocks marked by special characters, such as hashtag in Python/bash or rem in batch files, that instruct the script interpreter to skip executing the line, ensuring clean code readability. Domain 4.0 mini summary. Never wear an ESD strap when working inside high-voltage items like power supplies or CRT display structures. The change management workflow demands a structured plan, risk analysis, an explicit backout plan, and CAB authorization before implementation. Incremental backups clear the archive bit and save files changed since the last backup. Differential backups do not clear the archive bit. PII covers personal data like SSNs. PHI governs healthcare records. PCDSS applies to electronic credit card transactions. Match script extensions accurately. .ps1 is PowerShell, .sh is Bash, .bat is Windows Batch, and .py is Python. Before we finish this CompTIA A+ crash course, let's do a review of what we just covered in Domain 9 with a short quiz. Question 1. Which is an example of an environmental control used to protect data center equipment? A. UPS power protection. B. Door locks only. C. Password policy only. D. Screen brightness settings. Correct answer. UPS power protection. Explanation. UPS and other environmental controls help prevent outages and protect hardware. Question 2. What should documentation primarily support in an IT environment? A. Personal preference for naming files. B. Consistent operations, troubleshooting, and knowledge transfer. C. Eliminating the need for approvals. D. Stopping software updates. Correct answer. B. Consistent operations, troubleshooting, and knowledge transfer. Explanation. Good documentation enables repeatable support and continuity. Question 3. In change management, what is the typical goal of having an approval process? A. Allow changes without any review to save time. B. Reduce risk by evaluating impact before implementing changes. C. Replace backups with snapshots only. D. Remove asset tags. Correct answer. B. Reduce risk by evaluating impact before implementing changes. Explanation. Change approvals help prevent unintended outages or security issues. Question 4. Which backup and disaster recovery approach is designed to keep systems running with minimal downtime? A. Offsite backup with no restore testing. B. Cold storage only. C. A redundancy and replication or failover-ready architecture. D. Deleting old backups to free space. Correct answer. C. A redundancy and replication or failover-ready architecture. Explanation. Failover-ready designs reduce recovery time during disasters. Question 5. Which statement best describes software licensing compliance? A. Licenses are optional if you have the installer file. B. Licensing depends only on having admin rights. C. You must use software in accordance with the license terms and keep appropriate records. D. You never need to track licenses for regulated environments. Correct answer. C. You must use software in accordance with the license terms and keep appropriate records. Explanation. Licensing compliance requires following license terms and maintaining records for audits. You've now worked through every major section of Core 2. If you followed along with the visuals and explanations, you should have a strong understanding of how operating systems, security, troubleshooting, and professional procedures all connect in real-world environments. Keep reviewing, stay consistent, and trust the work you've put in.